Imagine a 40-kilogram child on a sled, and someone attaches a string to it and pulls it with a force of 60 newtons. The kinetic force of the slide is 40 newtons. It travels 20 meters. What is the work done on each force? So I drew the diagram which shows the sled, and we have the force pulling, which is 60 newtons. We have the kinetic force, which is pulling back at 40 newtons, and it's 20 meters long, and it's 40 kilograms. So I did a force diagram, which shows the sled, and we have four forces acting on it. We have gravity, the attention, normal, and we have force of kinetic. So we come down here and we're using the work energy. We're using the work energy formula, which is force times change in distance cosine. So we're going to put 60 newtons. We're going to start with tension. We're going to start with T. We're going to take 60 newtons times 20 meters times cosine 0. The reason it's cosine 0 is you see right here in this angle it would be 0, which gives us 1200 joules. Then we go to force of kinetic. Force of kinetic, we're going to use 40 newtons because we're doing this one. We're doing this force times 20 meters, which is the same as the whole distance, and cosine 180. The reason it's cosine 180, you got to think of as x and a y, and then we're going from this one all the way around. So from the y-axis this way, it's 180, which gives us a value of negative 300 joules. And the last one we have to do would be gravity. So we take 40 kilograms times 9.8, because we got to get kilograms to newtons, which equals 392 newtons. Then we take W and we set it to 3.92 newtons times 20 meters cosine 0, which gives us gravity, which is 0 joules.